In this video, we'll be talking about equations of lines and graphs of linear equations. In this video, we'll be talking about equations of lines and graphs of linear equations. A linear equation can be represented in three different forms: the slope-intercept form, the point-slope form, and the standard form. Now, the slope-intercept form is the most common form that you might see a linear equation in. It is represented by y equals to mx plus b, where m is what's called your slope and b is your y-intercept. And y-intercept is a point on a graph on which the line crosses the y-axis. The second form, point-slope form, is y minus y1 equals to m times x minus x1, where m again is your slope and x1, y1 is a chosen point. And the last form is the standard form, ax plus by equals c, where a, b, c are integers written in the lowest form and a is positive. If a is 0, then b is chosen to be positive. Now these three forms may look different, but they can be worked around, moved around in order to get to the desired form that you need, depending on the question. What's common between the slope-intercept and the point-slope form is the value m. M is what's called the slope of the line passing through both points, and is given by the formula m equals to y2 minus y1 divided by x2 minus x1. You can think of y2 minus y1 as the change in y, or the rise, and x2 minus x1 is a change in x, which is often called the run. Now, x1, y1, x2, y2 are two separate points, and you can use those 2 points and use the formula to find the slope of the line. Let's look at an example of how to find the slope of a line. So consider a line passing through the points 2, -3, and -1, 5. Find the slope of the line. So first thing we want to do is we want to label our points. Let's call the first point as x1, y1, and then our second point is x2, y2. So as stated before, the formula for slope is y2 minus y1 over x2 minus x1. So that tells us that for us, our y2 is 5 minus y1, which is -3, divided by x2, -1, minus x1, which is 2. So on top here, negative gets us positive, so 5 plus 3 divided by -1 minus 2. And -5 plus 3 gives us 8. And then -1 minus 2 is a -3. So it tells us our slope here for this line would be -8 over 3. Now we have a situation where we have a point and a slope, and we need to find the equation. So this example says, find the equation on a line that passes through the point 2, 7 and has a slope of 3. So right away we're given a point and a slope specifically. So we can use the point-slope form. So remember, the point-slope form says y minus y1 equals to m times x minus x1. So we can say that we know that our slope here is 3. So that right there is our m. And this point here can be represented as x1, y1. So plugging into our point-slope form, that should give us y minus y1, which is 7, equals to m, which is 3, and then we open parentheses, x minus x1, which is 2. Now normally, unless stated, you always want to write your equation, if you can, in slope-intercept form. So we want our equation to end up in the y equals to mx plus b form. This is the very nicest way to get it that represents it, because you have y on one side and everything else on the other. So let's get this equation in point-slope and convert it into slope-intercept form. So first thing we can do is on the right side, we can distribute the 3 into everything in parentheses. So it gives us 3x minus 6. And then what we do now is we want to get y by itself, so we want to add 7 to both sides. So that gives us y equals to 3x, negative 6 plus 7 gives us plus 1. So that is the equation of our line in slope-intercept form, in mx plus b form. There are a couple methods you can use to graph a linear equation. So this is an example here. Graph the line represented by the equation y equals to 5x minus 2. So one method is to plug in values of x to get the corresponding y's and plot those points on a graph and then just connect the line. So let's do that with this equation here. We have y equals to 5x minus 2. So first off, let's say when x is equal to negative 1. So we would plug negative 1 into x. That gives us 5 times negative 1 minus 2. 5 times negative 1 is negative 1, negative 5. Minus 2 is negative 7. So when x is negative 1, y is negative 7. So we plot a point down here. Next one, let's say when x is 0. When x is 0, we have 5 times 0 minus 2. 5 times 0 is 0, minus 2 is negative 2. So when x is 0, y is negative 2, which is right here. Now, you have 2 points. You can technically connect them now, but let's do a couple more. Let's do one more. So let's say when x is positive 1. When x is positive 1, you have 5 times 1 minus 2. 5 times 1 is 5, minus 2 gives us 3. So when x is 1, y is 3. So we have 3 points now. With those 3 points, we can connect our line. If we do so, sketch it. Something along the lines of that. So that is the equation of our line using by plotting points. Now what happens if your line is a little bit more complicated, as in it's not as easy to plot x values to plug in x values to get y values out of it. So we look at this example here. Graph the line represented by the equation y equals to negative 2 over 3x plus 3. So this one's a little bit more complicated because our slope, our m, is negative 2 over 3. So it'll be harder for us to plug in x values to get nice whole numbers in our y, such that it makes it easy to plot on our graph. So what we can do is use the rise over run method. So how that works is first is we want to identify that our equation here is in slope-intercept form. It's in the mx plus b form. So we know that if it's mx plus b form, we know that our slope, our m, is negative 2 over 3, and our b, which we mentioned earlier as what's called our y-intercept, is 3. So because our y-intercept is 3, we know as a point it's always 0, comma our b value, which is 3 in this case. So right away we have our first point that we can plot. We plot 0, 3, which is right here. Now, we can find a second point. Instead of plugging in x value, we can use the rise over run method. So when rise over run, we automatically think of our slope. So right here, our slope is negative 2 over 3. Now that negative sign can go either on top or on bottom, but can't go on both. So let's say for simplicity's sakes, we put that negative on top with the 2. So we have negative 2 over positive 3. Because it's rise over run, but it's going negative, what we're actually thinking about is like saying we're going down 2. Because when it's negative, instead of rising, you're actually going down. Because rising means going up or down, but because it's negative, you're going down. And the bottom, when you're running left or right. Right would be represented by the positive. So because it's a positive, you're actually going to the right 3. So what we can do now is from that point, that intercept, 0, 3, we can go down 2 and right 3. And that gives us the second point. Now, going back to the y-intercept, you can actually go opposite. What I mean by that is I can actually go up 2 and left 3. Because when I'm going up 2, that means my 2 is positive, and when I'm going left 3, my 3 is negative. Because negative 2 over 3 can also be written as 2 over negative 3. It gets you the same result. So because of that, you can go either down 2, right 3, or up 2, left 3. Either method will give us the same points on the line. So connecting the dots on this line here gives us something like this. And that right there is the equation, graphing the equation of a line using the rise over run method. There are also equations of vertical and horizontal lines. The equation of a horizontal line that goes through the point AB is represented by y equals to b, where the y-intercept is b. So since y2 minus y1 would be equal to b minus b, which is equal to 0, there's no rise. So the slope of a horizontal line is just m equals 0. As opposed to the equation of a vertical line, it goes to the point, let's say CD, then x is equal to c. The x-intercept of this line is c comma 0. So it just crosses through the x-intercept. And again, since this time, x2 minus x1 would be c minus c, that would be equal to 0. There's no run. But remember, the run is on the bottom of the fraction. But we can't have a 0 on the bottom of a fraction, thus the slope of a vertical line is undefined. Two linear equations can be parallel and perpendicular as well. To determine if they are, it's as follows. Two different non-vertical lines, let's say L1 and L2, are parallel if and only if they have the same slope. So the slope of L1 is equal to the slope of L2. If we have two different non-vertical lines, L1, L2 again, are perpendicular if and only if the product of their slopes are -1. Or another way to think of it is the slopes are negative reciprocals. So you can think of it as the slope of the first line times the slope of the second line gives you -1, or the slope of the first line is -1 over the slope of the second line. Let's look at an example. Write an equation in slope-intercept form of the line that passes through the point -1, 3 and satisfies the following conditions. So part A says parallel to the line 2x minus y equals -1. So as we were talking about earlier, in order to find the parallel line to this equation here, we need to find the slope of this equation first. So to do that, we want to get this equation into mx plus b form, the slope-intercept form, because that helps us easily identify what the slope m is. So doing that, let's rewrite this as 2x minus y equals -1. So I subtract 2x over to the right side, gives us -y equals to -2x minus 1. Then we can multiply the whole equation by -1 to make that y positive, and in turn flips all the signs. So that gives us y equals to 2x plus 1. So we can say that the slope of this first line here, slope of m of L1, is 2. So because the second line is parallel to this one, we can automatically say that the slope of L2 would also be 2. And given that point, it passes through the point -1, 3, we now have a point and a slope. We can use point slope form to find our equation of the line. So we know that y minus y1 equals to m times x minus x1. So y minus our y1 is 3, m, which is 2, times x minus x1, which is -1. So it gives us 2 times negative is +1, y minus 3. Distribute the 2 into parentheses, so we have 2x plus 2. And the last step is just add 3 over to the right side. So if we go over here, that tells us the slope, the equation of our second line will be 2x plus 5. And that is written in slope-intercept form. Now what happens if you want to find a perpendicular to the line 2x minus 1 equals to 1? So as worked on the last part, we know that the slope of this line is 2. So we can say m of L1 is 2. Now, that means that because the line that we're looking for is perpendicular to this line, we know that the slope of m of L2 has to be the negative reciprocal. So m of L2 would have to be negative 1 over the slope of L1. So it would be negative 1 over 2. So again, because we know the slope and we know that the point passes through negative 1, 3, we can again use point slope form to find the equation of our line. So we do y minus 3 equals to negative 1/2 times x minus 1. So that's negative 1/2 times x plus 1, y minus 3. Distribute the negative 1/2, negative 1/2 x minus 1/2, 3. And then we add the 3 over to the right side. So we would have y equals to negative 1/2 x. And we know that negative 1/2 plus 3 is 2.5. 2.5 as a fraction is 5 over 2. And that is the slope, that is the equation of the perpendicular line.